Good morning. This is Ms. McKibben. It is Thursday, March the 26th, and today in pre-calculus we are going to be working on verifying trig identities. When we verify an identity, it's extremely similar to simplifying. However, it has a left side and a right side of an equation. However, you are only going to work on one side of the equation. As it says here, you're going to simplify the left and or the right side of the equation until they are the same. So generally speaking, I kind of pick the side of the equation that's more complex, and I start simplifying it until I get it to match the opposite side of the equation. You cannot move from one side of the equation to the other side. It's not like you're solving an equation where you'll divide something over or subtract something over. You pick one side, left or right, and simplify it down until it matches the other side. This is almost like solving a puzzle, kind of. You've got to figure out how you can get one side to equal the other side. And big thing here, you need to show every step. Assume I know nothing and you have to prove everything to me. Act like I don't know anything about identities as you're simplifying these. Make sure you show every step. I've got to be able to read it from beginning to end and be able to follow all of your work. So for example, on number 1 right here, obviously I'm going to simplify on the left side. All I have on the right side is a 1. Over here I have tangent, cosine, sine. So I'm going to simplify this right here. The same hints apply as with simplifying. Switch things to sines and cosines. And if you see pluses or minuses, think about your Pythagorean identities. So I'm going to start off right here. Tangent I know is sine over cosine. That's sine x over cosine x. I'm going to leave the cosine in the numerator as a cosine. And then in the denominator I have sine. And that all equals 1. Now in my numerator I can cancel out these cosines. Cosine cancels with cosine. And now I have sine x over sine x. And as we know, anything over itself is always 1, so this becomes 1, and I have 1 equals 1. And I've proved that these two sides are identical to each other. Again, the two hints, switch to sines and cosines, or if you see pluses or minuses, think about your Pythagorean identities. So over here on number 2, I see 1 plus tangent squared. Well, anytime I see a plus or a minus, I'm thinking Pythagorean identities. And I know 1 plus tangent squared equals secant squared. So I'm going to rewrite that as secant squared x over cosecant squared x equals tangent squared x. I forgot to say, obviously, I'm simplifying the left side because it's more complex. Secant squared is cosine. So the numerator can be written as 1 minus cosine squared x. Cosecant squared is 1 over sine squared. And then what I have on the left here is a fraction divided by a fraction, so I can keep, change, and flip. Keep your numerator, change to multiplication, flip the denominator. I'm sorry, that's over 1. And then once I multiply these, I do have sine squared x over cosine squared x, which does equal tangent squared x. Be sure that your final answer always has the exact same thing. Like, I know this is tangent squared x, but I want to see you write it as tangent squared x. In the end, the left side and the right side should be identical. Tangent squared x equals tangent squared x. All right, on number 3 here. Sometimes you might want to factor to make things easier. Like when I see a cosine squared here and a cosine squared there, I could factor out a cosine squared. This identity really has two different ways you can go about verifying it, and a lot of times they will. If I first factor out a cosine squared, then I'll be left with 1 plus tangent squared x equals 1. Well, 1 plus tangent squared, remember, is equal to what from our Pythagorean identity? Secant squared x. And these two are inverses of each other. Secant squared is the same thing as 1 over cosine squared. And then those can cancel. And I have 1 equals 1. Be sure that when you switch from like 1 plus tangent squared to secant squared, that when you rewrite that, it's 1 over cosine squared, not just 1 over cosine. You've got to remember the square in there. The other option of how you could have verified this was switch, to sines and cosines without factoring something out. Cosine squared plus cosine squared times sine squared over cosine squared x. Kind of running out of room there. Here, those can cancel. And I would have cosine squared x plus sine squared x, which is 1. So 1 equals 1. Either option works. As long as you can get them to be the same thing, that's fine. I just have to, step by step, show me how you're getting there. Over here, 1 over secant squared plus 1 over cosecant squared. Well, I'm going to switch to sines and cosines. 1 over secant squared would be the same thing as cosine squared x. 1 over cosecant squared x would be the same thing as sine squared x. Cosine squared plus sine squared is 1 equals 1. From the Pythagorean identities, cosine squared plus sine squared is 1. So I don't need to show anything else there. All right, number 5 here. Cosine times cosecant minus secant equals cotangent x minus 1. I don't know, the first thought that comes to my mind is to distribute this through. So that would give me cosine x times cosecant x minus cosine x times secant x. And that's all equal to this cotangent x minus 1. All right, switch to sines and cosines. This is a cosine, so I'm going to leave it alone. Cosine x, 1 over sine x, cosine x, times 1 over cosine x equals the cotangent x minus 1. Well, this right here is cosine x over sine x. Cosine x over cosine x, anything over itself's 1. And so that gives me cotangent x minus 1, which is equivalent to cotangent x minus 1. I've just verified that they're the same thing. All right, moving along. Right here, on the first 5, we did simplify the left side all the time, but that will not always hold true. It really just depends on the problem. You look and decide which is the more complex side and where you want to start tackling it. So number 6 here. I don't see any pluses or minuses, so I'm going to switch things to sines and cosines. But not on the left. I've got to leave one side alone, so I'm going to leave that as tangent. And I'm going to come over here and start switching stuff. That's cosine x, sine x, and then cotangent squared x. Pay attention to the fact that this is squared. Would be a cosine squared x over a sine squared x. Now this can simplify, and I'm just left with a single sine x down there. So it's like tangent x is equal to cosine x all over cosine squared x over sine x. I'm going to keep changing flip on the right. I'm going to keep cosine x. I'm going to change to multiplication, and I'm going to flip the sine x. Here we can reduce. Tangent is sine over cosine. So now I have the tangent of x is equal to the tangent of x. I have verified that the right side and the left side are identical to each other. All right, number 7. It looks like it has a lot going on. Obviously, I'm starting on the left. I'm going to first start with switching to sines and cosines and see if that helps. A lot of times, you have to back up and start over, but that's my first thought always. So cotangent x is cosine x over sine x. Secant x is 1 over cosine x. Cosecant squared x is 1 over sine squared x. Minus cotangent cubed is going to be cosine cubed x over sine cubed x times 1 over cosine x. And then obviously the right side's just going to stay that cosecant x. So let's see what we can simplify out. We have got a cosine and a cosine will cancel. So down here I have 1 over a sine to the first times a sine squared gives me a sine cubed x minus cosine cubed. Oh, nope, let me back up. Let me simplify over here first. Sorry about that. Right here, this can reduce. A cosine will reduce with a cosine cubed and become a cosine squared. So now I have minus cosine squared x all over sine cubed x. Still have my cosecant. Since these have like denominators, I'm going to go ahead and put them together. Give myself just a little bit more room. Okay, again, since the denominators are the same, I'm going to put them together. 1 minus cosine squared x all over sine cubed x. And then by now you should start recognizing anytime you have, pluses or minuses, 1 minus cosine squared, I know is sine squared x over sine cubed x equals cosecant x. And then this can reduce, just like you would reduce any variables. This would cancel, leave you a 1. This leaves you with a sine x. And 1 over sine x is cosecant x. So I get cosecant x equals cosecant x. Just, kind of start tackling them step by step. Again, just like simplifying, the hints are switch to sines and cosines, as well as if you see pluses or minuses, think about your Pythagorean identities. All right, number 8. This will be our last one. Obviously, I'm going to start on the left side. So I'm going to switch to sines and cosines. So I've got sine x over 1 over sine x plus cosine x over 1 over cosine x. And then with these, I can, keep change and flip on both of them. So this will become a sine x times a sine x. This will become a cosine x times a cosine x. Keep the numerator, change to multiplication, flip the denominator. So now I have sine squared x plus cosine squared x equals 1. That from the Pythagorean identity is a 1, so I have 1 equals 1. All right, I know that can be a little bit overwhelming for some people. They are puzzles almost that you've got to figure out, and you've got to make the left side equal the right side. We're going to be practicing on this both Thursday and Friday. I will post more information on the blog. I hope everyone has a great Thursday. And if you need me, as always, please send me a remind or an email. Although remind will get you the fastest response because I'll get it right on my phone. Take care and stay well.